So, hello everyone, welcome back to our module 2. So, this module 2 is this is covered from week 3 to week 4. So, in this module 2, we are going to talk about rational functions, equations, and inequalities. So, before we're going to start, please be ready with your modules and then calculator, ballpen, and scratch. Okay, so I am again your subject teacher, and I'm welcoming you all to week 3 to week 4. So let's start. So in this module, we are having 4 lessons. We have rational functions, equations, and equalities, solving rational equations, inequalities, representation of rational functions, graphing rational functions. So these are the 4 major topics that we're going to discuss in this module 2. I know it's very big, huge lessons. It's very long, but I hope this video will help you to learn these different lessons. Okay, so to start with, we have lesson 1. So what is a rational function? What is irrational, by the way? Rational. So when you say rational, when you're going to talk about numbers, so we have here the representation of rational. There you go. So real numbers. So a rational is here, this one, can be represented as a fraction or a ratio. So it is under the real numbers. So again, rational can be represented as a fraction or ratio. So we have here, okay, so we have irrational. So integers can be irrational, whole numbers can be rational, and natural numbers can be rational. So when you say integers, say for example, you have negative 8 over 2. So these are what we call integers, the positive and negative numbers. So we have negative 8 divided by 2. The answer is negative 4. So rational numbers. So what is a rational function? So can be modeled a real life situation, particularly that, okay? So real life situations that involve rational function is mostly seen in economics and science. However, other disciplines also incorporate this concept. Example for rational functions are: write a function C that represents the cost of buying alcohol A if an alcohol costs 1.5. So if you want to know the price, so you can represent this one as a rational function, right? So this A represents here the a number of alcohol that you're going to buy. Say for example, your A is 2, meaning you are going to buy 2 alcohol that cost 1.5 each. So if you're going to substitute this 2 to A, then you have this will become 155 multiplied to 2. So the cost that you're going to pay for 2 alcohol is 310. So again, this function here represents the formula to know what will be the how much you're going to pay, or what's the cost of the total alcohol that you bought. Second, a commuter pays 20 pesos for a tricycle ride for the first 5 kilometers and an additional 0.75 for every succeeding distance, where D, that represents D in kilometer, represents the situations as functions. So this is what the function represents for. Okay? So in definition of polynomial function, you have here, also in your module, a polynomial function of degree. So this is what we have here. Wait, okay. So we have a polynomial function p of degree. So we have the term, we have coefficient, leading coefficient, and the leading term, and the constant term. So for example, you have here 2x squared plus 3x minus 3. So what do you think? How many terms do we have in this polynomial function? So in this polynomial function, we have terms is 3. Why? Because this is one, the first one, this is the second one, and this is the third one. So we have 3 terms. Next, what are the coefficients? The coefficients are what? Numerical coefficient or the literal coefficient. So when you say numerical coefficient, numerical, we are talking about here numerical coefficients. So when you say numerical coefficient, this belongs to 2 and 3. So that is the numerical coefficients. So when you say literal coefficients, I'm going to use this red. So we have here the x, and the other one is the x. That is the literal coefficient. Now what is this 3? What do you think is this 3? What do you call this 3? 3 is what we call the constant. Very good. So that is the constant term. Okay? The leading term is this one. That is the first one, of course. The higher the degree, that should be in the first. So what's the degree of this polynomial? That is the second degree. Second degree. Okay? So this is just a sort of review when you have, I know for sure it was already discussed to you in junior high school. So let's proceed. So say for example here, the local government unit allotted a budget of 100,000 for the feeding program in the daycare center. The amount will be divided equally to all pupils in the daycare center. Write an equation showing the relationship of the allotted amount per pupil represented by f of x, okay, versus the total number of children represented by x. So we have here, be careful with the term, so that would be the let f of y, we will know the allotted amount per pupil, and this x represented the total number of children. So we have here the table, number of children, that is x, and allocated amount per children, that is question y. We are going to solve for that one. No, that is not question mark. That is our pupils represented. That is our f of x. So how are we going to get our f of x? Given that we have allotted budget of 100,000 and number of children we have 10, 20, 50, 100, and 200. So by that we are given here a function which is f of x is equals to 100,000 over x. Okay, so this x you can substitute it by 10, by 20, 50, 100, and 200. Why did we divide it? Because we want to know the allocation amount per child. So if we're going to divide it by 10, if we're going to use it by 10, so 100,000 divided by 10, the per child, the allocation of that child, each child is 10,000. If it is 20, what do you think? That is 5,000. Then you follow, you solve it on your own to know what is the allocated amount per child. If it is 50, 100, and 200, it's your turn. So we have now the definition of rational function is a function of the form f of x is equals to p of x over q of x, where p of x and qrx are polynomial functions. Remember that, polynomial functions. And q of x is not a zero function. Should not be equal to 0. Why? Because it will make the equation undefined, right? So the domain of f of x is all values where q of x should not be equal to 0. So our domain is, remember, we already discussed what is domain, that is the value of x. The result would be the y. Okay. So a car is to travel distance. Let me give you an example. Say for example you have your x over x minus 2. What could be the domain here? So the domain is what? Okay, the domain is what what number can you substitute to x? Okay, so what number can you substitute to x? So what number can you substitute to x? Be sure that the q of x should not be equal to 0. Okay, remember that. Or the denominator should not be equal to 0. So, of course, what will make this, what number can you substitute to x that will make this 0? Diba 2? Because 2 minus 2 is 0. So, dapat, we are not going to put 2 in our domain. So, it could be all real numbers minus 2 or except 2. Okay, because why except 2? Because 2 can make the equation or the function undefined. Okay, I hope it's clear. Let's have another one. 2x over what? X squared. X squared. Yes. Plus, let's have 9. Yeah. We have 2x over x squared minus 9. Let me undo. Okay, I have 2x over x squared minus 9. So what do you think is the domain? Okay, what is the domain here? Can we have all real numbers? Can we substitute here? What is specific? So first thing that you're going to look at is the denominator. You should look for a number that will make this denominator 0, and then that number will not be included in the domain. Okay, so because it's easier to find what number that will make it 0 than to substitute all the numbers. Okay, so baliktad. We have to look for a number that will make the denominator 0. So what number can be substitute to x that will make this denominator to 0? So it could be positive and negative 3. Let's check. I'm going to use red ball pen for checking. So we have 2. Alright, 3. Positive yan ha. Tapos 3 squared minus 9. So that will become 6 over 3 times 3. That is 9 minus 9. That is 6 over 0. See? Again, the denominator should not be 0. And then the other one is 2 raised to negative 3 over negative 3 squared minus 9. So we have negative 6 over, again, because negative times negative is equals to positive, so we have 9 minus 9, that is still negative 6 over 0. So that's why we have this negative and positive 3 is out in the domain. So we can have a real number except positive and negative 3. Okay, so that could be our domain. So be careful again how to get the domain. Look at the denominator, look for a number that will make the denominator 0. Then you are not going to include that number. Okay, so that is how you're going to get the domain. So let's proceed here. So what is the difference between rational equation, rational inequality, and rational function? So when you say rational equation, an equation involving rational expression. So we have here equal sign. Rational expression, this is polynomial, okay? So that is equation from the word equation, equal. Okay, next, rational inequality, involving an inequality involving rational expression. So this will make it inequality. It could be greater than, less than, greater than or equal, less than or equal. So those are the symbols that will make the equation a rational inequality. And the rational functions, we are using f of x, and also this can be also y. Okay, again, remember that the denominator, this one should not be equal to 0. Okay, so we have here an examples. So this is a rational expression. Why does this number 3 and not a rational expression? Because of this square root here. Okay, since the numerator is not a polynomial. Okay, that makes this expression not a rational. Next, this is rational expression because remember the denominator of that one is 1. Same as 3. What is the it is a what's this? A fraction, given that the denominator is 1, diba? That's just equal to 3. Number 5, this is a rational function. And number 6 is not a rational function because of this square root of 2. Okay, let's practice. How about this independent practice one? What do you think is the answer? Skidal, you try. What do you think is the answer? The answer for number 1 is... Yes, you're correct. That is rational equation. How about number 2? What's the clue? Very good. This is the clue. So that is rational inequalities. Good. How about number 3? This one. That is the clue. Okay, that is a rational function. How about number 4? Hint. Y is represented by f of x. So f of x, is this a polynomial? Yes. Is the denominator polynomial? Yes. Okay, that is a rational function. How about number 5? Is this a polynomial? Let me zoom it. Alright. Is the numerator polynomial? Yes. The denominator polynomial? Yes. How about this one? Is this a polynomial? No. Therefore, your answer is none of this. Very good. So I hope you know the difference between rational equation, rational inequalities, and rational functions. I will be back to our lesson 2 video. Thank you and God.